Welcome to Study Loop.
Problem 8.73, we have these two blocks of orange ice sliding in a frozen valley made of gray ice, I guess. This is approaching this one at 12 meters per second. This one is at rest. They will stick together when the first one hits the second and then slide together up the wall of the valley. And what we would like to know is, to what height do they slide? Let me draw that so it doesn't go off the top. Okay. So this has examples of both conservation of momentum, because we have an inelastic collision taking place in a frictionless world, so momentum's getting conserved. And conservation of energy, because we're going to start off with some kinetic energy, and all of that's going to get turned into potential energy before our ice blocks start sliding back down. And again, because there's no friction, none of the energy is being lost to sliding friction. So we want to know how fast the combined object is going to be going. So they both have the same mass, so let's call that 2m. The final velocity, final as in after the collision occurs, is equal to m the initial, and so the final here is equal to 1/2 the initial, or 6 meters per second. Now for the conservation of energy, our object will have a mass of 2 little m. The gravitational potential energy is going to equal the gravitational potential energy at whatever height it gets to is going to equal the initial kinetic energy, which is 1/2, mass is 2m, V final squared. Again, this is final after, not the V final up here is 0, but V final is in final after the objects have collided. Turns out it doesn't really matter too much what the masses were. And we see that our height is going to be Vf squared over 2g. And this works out to be 1.84 meters. So that's how high it's going to get before starting to slide back down.